Yeah, so screen is visible, right?
Yes, sir.
Okay. Yeah, so basically if you have Fe2CO9, Fe2 CO9 structure, okay, compound, so you have iron, okay, this side you have also iron. Now 3CO you have to place here, okay, 3CO here, okay, and 3CO will do bridging.
Yes, sir.
Yeah, so this is the structure of your Fe2CO9
Sir,
compound, right? So if you know
contaminated.
that iron, if you consider that iron is a neutral, okay, suppose
Okay.
iron is neutral, so that means how many electrons you have? What is the electronic configuration of iron?
Valence
3d6
in.
4s2, right?
Yes, sir.
3d6 4s2, so that means you have total 8 electrons. So if you
Yes,
see
sir.
here 1 2 3 4 5 6, okay, 6 bond,
Sir,
because iron actually forms 6 coordinate compounds, okay.
to
Hmm.
write the metal bond.
Ha. So when you know already that CO ligand is like that, right? CO ligand is like that, so it can donate only 2 electrons.
Yes,
And
sir.
the CO ligand is responsible for 2 electron donation, so it is donating 2 electrons to here, here, here. But when it comes to bridging ligand, so that means suppose this carbonyl CO is donating 2 electrons to this iron center, okay, so that time what is happening, iron is actually donating 2 electrons to this carbonyl also, okay, to form this bond. These are all coordinate bonds, okay, these are not your covalent bonds. Now similarly, suppose this bridging CO, this is donating 2 electrons to your iron center, so that time this iron center will donate the 2 electrons to form this bond with carbonyl, okay. So
Okay, sir.
like this the bonding is happening, okay. So you cannot form here 4 bonds. If you see here, so 1 2 3, suppose here you have 2 electrons, 2 4, okay, 1 2 3 4, and here it is donating 2 electrons. So if you form 4 terminal bond, that time it is not possible. Now why not possible? Because if you form 4 bonds, so that means already CO is donating electrons to your iron center, and iron has 8 electrons, so that it cannot donate symmetrically, okay, just a minute. So it cannot donate actually symmetrically, okay. So you just remember this, that if you have Fe2CO9 structure, 3 will be your terminal, and 3 will be terminal to both the iron centers, and 3 carbonyl will be your bridging, okay.
Yes, sir.
Okay, up to what we have done?
Cobalt for CO12, sir.
Cobalt.
For CO12.
Okay, okay, now to this only, fine. Okay, now do for this question, try to solve. Suppose you have CO2, Fe2, CO11, mu4, pph whole 2. Okay, so find the number of metal metal bond, and per metal atom how many bonds you are getting. So what is the formula you have? 18n minus what?
Total
Total
valence
valence
electron
electron
by
divided
2.
by what?
2.
Divided by 2. So do it. N is equal to your number of metal atoms
The answer is 2, sir.
2, no, check. 2, no. Tell me this, mu4 pph whole 2, mu4 pph, this ligand donates how many electrons?
8 electrons.
8 electrons, so correct na. Then why, where you are doing mistake? How many metal centers you have here? How many metal atoms you have?
4, sir.
4, so 18 into 4 minus total valence electron or valence electron. Find out the valence electron. So for cobalt, how many electrons you have for cobalt? 2 into 9, right?
Yes,
For
sir.
iron it will be 8, so 2 into
2 into
8. For carbonyl it will be 2, so 2 into 11. And pph, so that means phosphorus has how many valence electron? 5 valence electrons phosphorus has. You have pH, so already one electron is already involved in this bonding with pH, so that means 4 electrons left for phosphorus. Okay, so and you know what is the meaning of mu4? So mu4 means it is actually doing bonding, it is actually bonding with 4 different metals. Okay, so mu4 means it's a bridging ligand and it is bridging with 4 different metal centers. Okay, not like
Answer is 4.
4. So 2
Okay.
into 11, and for mu4 pph, so 1 pph unit is donating 4 electrons, so that means 2 pph will donate 2 into 4. So if you see the total valence electron, so how much you are
60.
getting? 64, right?
Yes, sir.
64, so 18 into 4 minus, 64 divided by 2, so you will get what? 72 minus 64, so 8 by 2 is equal to what? 4.
4.
Okay.
Yes, sir.
Okay, and per metal atom, number of metal bonds per metal atom. So it will be what? 18 minus valence electron divided by what? Divided by n. Okay, not 2. So 18 minus valence electron is your
64 by 4.
4. Right?
Yes, sir.
So you are getting what? 18 minus
And
what? 16.
16 is equal to 2.
Clear?
Yes, sir.
Fine. Chandana, clear? Clear? Any doubt?
Sir, clear, sir.
Yes, left. Okay, fine.
Sir, this calculation is neutral method or ionic method?
Neutral method. We are considering on neutral method here. Okay. Ionic means you have to consider the positive charge and negative charge. Negative charge means you have to add electron. Okay. Positive charge means you have to subtract electron. But when you are considering neutral method, so that means cobalt is what? 3d7 4s2. So that means total you have 9 electrons. Iron is 3d6 4s2. So total you have 8 electrons. Okay.
Okay, sir.
Okay. So suppose you have tungsten, then you have eta 5, C5H5, mu Cl, CO whole 2, whole 2. Find it out. Switch off the mic. Turn off the mic now. Otherwise, later.
Five, sir.
what you are getting?
5 metal bond.
5. So first of all you have to write down like this, so whole 2, right? So you just write down like this, W2, then write down eta 5, C5H5 whole 2, okay, then you have mu Cl whole 2, and this CO, carbon monoxide, will be whole 4. Okay, so now tungsten is donating how many electrons? So check which group member it is: chromium,
6
molybdenum, tungsten. So it will have also 6 electron, right?
6
So
electron.
first of all, if I do the valence electron calculation, so for tungsten it will be 2 into 6. Okay, for cyclopentadienyl,
5 into 2.
5 into 2. Now the question is for Cl, mu Cl. So this is not your normal chloride ligand. Okay, this is your uh, bridging chlorine ligand. Okay, bridging chlorine ligand. So if you see how many metal centers you have, 2
2.
metals, right? So that means chlorine is doing covalent bond with one metal center, that is automatically. And how many valence electron chlorines have? 7 valence
7.
electrons. So out of these 7 valence electrons, already one electron is involving covalent bonding with this tungsten, and this electron pair, okay, this electron pair, that will donate to the other metal. Okay, that will donate to the other metal, because bridging ligand means what? Bridging ligand means at least you need 2 metal centers, right? Otherwise you
So,
cannot consider it as your, if it is doing bonding with only one metal center, so that means it is a terminal ligand. Okay, so at least 2 metal centers should be there. So that's why they have written nothing is there, so that means mu 1. Okay, so basically how many electrons chlorine is donating?
3 electrons.
3 electrons, so it will be your 2 into 3. And for carbon monoxide, you know, it will be your 2 into 4. Okay, so if you add them, what you are getting? 12 from here, okay, 10 from here, 2 plus 3 6 from here, and 2 into 4 8
36.
from here. So 12 into 10, 22, 28 plus 8, so it will be what?
36.
36. Okay, so 36. So that time this kappa value will be what? What is the formula we have? 18
18 into
n minus valence electron divided by 2. So how
2.
many metal centers you have here? 2,
2.
right? So it will be 18 into 2 minus valence electron will also be what?
36.
36 divided by 2, so it will be what? 0. So here you will have 0 metal bond. Is it clear?
Yes, sir, clear.
Write it down.
Complete, sir.
Done, right?
Yes, sir, done.
Okay. Okay, now try to do this one. Cp Fe do it.
2 answer.
Hmm?
2.
2 you are getting. Check again, check. This is the thing, okay? Whole 2 means like this,
0,
right?
0, sir.
So valence electron, if you see, so cyclopentadienyl, it will donate you 5 electrons. Iron will donate how many electrons?
8.
8. Carbonyl,
2.
2. And nitrosyl,
3.
3. So how much you are getting? 10 plus what? 16 plus 4
4
plus 6.
plus 6.
So 10 from here, 10 from here. 20 plus 16,
26.
36.
36.
Right.
Yes,
Now
sir.
put in the formula. How many metal atoms you have here?
2.
2. So 18 into 2 minus valence electron is what?
26.
36. Then how you are getting 2? It is also 0, na?
0. Yes, sir. Per metal is also 0.
Per metal will be also 0. 18 minus your 36 divided by 2. So again 18 minus 18 is equal to 0. Okay, per metal will be 18 minus 36 divided by number of metal atoms. So it is also 0. Both are 0. Okay, if your total value is 0, so that means per metal will be automatically 0. Okay, no need to find. Okay.
Okay, sir.
Okay. Do this one.
Sir, 1.
1 you are getting.
Yes, sir.
Correct. So here also you have to write down like this: Cp2, molybdenum 2, and CO is becoming 6. Now valence electron will be what? 2 into 5. Now for
5.
molybdenum, how many electrons you have?
6 electrons.
6 electrons. For carbonyl it will be 2 into 6. So 10 plus 12 plus 12, right? So it will be
Yes, sir.
34.
34.
Yeah. So now K value will be what? How many metal atoms you have? 2. So again 18 into 2 minus valence electron is 34 divided by 2. So 2 by 2 you will get 2 by 2 is equal to what? 1.
1.
Okay.
Yes, sir.
Fine. Now suppose you have this WO2 OPH whole 6.
So 3, sir.
3 you are getting. How you are getting 3?
So OPH it will donate 3 electrons, sir.
3 electrons. How? Explain it. So
So
OPH, oxygen has how many valence electrons?
uh, 6, sir.
6 valence electrons, right? So you have pH, OPH. So that means 1 electron is already involved in bonding. So you have 2, 4, 5 electron left,
Yes, sir.
right? So now, so this odd electron will do terminal, okay? This odd electron will do covalent bonding with your tungsten metal. So that time it is acting as your terminal ligand, and when this OPH is donating this lone pair to another tungsten atom, okay, tungsten atom, that time it becomes your what? It becomes your bridging ligand, okay.
Bridging, yeah.
So here actually two things are there. If you consider terminal ligand, so write down first of all that whatever you have got, that is actually correct answer, okay.
Okay, sir.
But write down this because that also you have to know. So considering OPH as a terminal ligand, okay, considering OPH as a terminal ligand, so what will happen if I consider as a terminal ligand? So that time the valence electron calculation will be, for tungsten it will be 2 into 6, okay, and for OPH if you see, so suppose a terminal ligand, so that means it is donating how many electrons? Only 1 electrons, right?
1 electron.
And you have 6 OPH, so that means 6 into 1, so you will get 18 valence electron, okay. Now if you put in the formula, so you have 18 into n, so how many atoms you have? Metal
2.
atoms 2,
2,
minus
2.
valence electron is 18
18.
divided by 2. So basically you are getting 18 divided by 2, which is equal to 9, okay. So you have only 2 metal centers and 6 bridging ligands you have, okay, but you are forming 9 metal bonds, so that is practically not possible, okay. If you have 2 metal centers and you are getting 9 metal bonds, so that is practically not possible, okay. So now the thing is, you have to considering OPH as bridging ligand, considering OPH as your bridging ligand. So that time what happens? So if it is acting as a bridging ligand, so that means already it is donating 1 electrons to one tungsten center, and the other lone pair it is donating to the other tungsten center. So basically it is donating 3 electrons, okay. So now it will be 2 into 6 for your 2 tungsten, and it will be 3
3 into
electrons
6.
it is donating. You have 6 OPH, so 12 plus 18 it is equal to 30.
30.
So K is equal to, it will be 18 into 2 minus 30
30.
divided by 2, so you are getting 3, okay. So this is
Yes, sir.
basically your correct answer, okay. So OPH, if they are not mentioning anything that whether it is acting as a terminal ligand or bridging ligand, so you have to check like that, okay.
Okay.
Okay, suppose next you have this CO whole 4, vanadium mu Pr2 whole 2, vanadium CO whole 4. Do it.
So answer is 3.
Answer is 3. Close. Not 3.
The two metal centers are right, yes, sir.
Two metal centers, correct, two metal centers. So basically if I write down in general, so it will be CO whole 8,
Right.
V2 and mu PR2, that is whole 2. So now valence electron will be what? For 8 carbonyl you will get 2 into 8. Okay, for vanadium it is donating how many electrons?
Electrons.
3 electrons and PR2. So now the thing comes PR2. So that means automatically the phosphorus is making 2 covalent bonds with 2 alkyl groups. So how many electrons left? 3 electrons left, right? So don't write down 3 electrons like that, because you know already that 3 electrons, write down like this. So you have 2 vanadium, so with 1 vanadium it will form a covalent bond, then it is acting as a terminal ligand. And if it donates this lone pair, because they have already given you mu, so that means it is acting as a bridging ligand. So that means this lone pair it is donating to the other vanadium center. So overall it is donating 3 electrons. So it will be 2 into 3. So 16 plus 6, 22 and plus 16. Okay, vanadium is what? Scandium, titanium, vanadium, right? Oh, sorry, it will be 2 into 5, right? Vanadium is what? 3d3 4s2. 3d3 4s2. So you have 5 electrons from each vanadium center, so 2 into 5. So 16 plus 10, 26 plus 6, so it will be your 32.
32.
Okay, 32. Now keep the formula. So 18 into number of metals, so you have 2 vanadium, so 18 into 2 minus valence electron is what? 32 divided by what? 2. So what we are getting? 4 by 2 is equal to 2. Clear?
Sir.
Suppose you have manganese, mu, pH2, CO whole 4, whole 3. Do it.
Answer is 0. Metal metal bond.
0. So 3 manganese you have, then what you have? Mu, pH2 whole 3, and this one will be CO whole 12, right?
Yes,
So
sir.
now valence electron, if you see, so you have manganese. So manganese means how many electrons you have?
Valence 7.
7. So it will be your 3 into 7 plus pH2. So it is a bridging ligand. So again 3 electrons left, right? You have
3 manganese.
3 manganese. So basically it will donate 1 electron to each manganese. Okay, 1, 2, 3. So it is donating 3 electrons. So that means 3 into 3, and carbonyl you have 2 electrons. So 21 plus 9, which is 30
24.
plus 54, right?
54.
54 you are getting. So K is equal to, it will be 18 into n
3.
value. N value is your 3
3.
minus valence electron, which is 54
54.
divided by 2. So you are getting 0. Okay.
Yes, sir.
Okay, correct. You got it correct. Now next question. Suppose you have this Cp3, Ni3, mu3, Co whole to the power z. Okay, here they have given one data, that write down given you have 3 nickel bond. Okay, you have 3 nickel bond. So yeah, find out the z value.